question doesn't really have any instructions. It just is to solve. And we can talk about some features, but I presume there'll be some aspect of solving here. So when you look at this, it's a 4th degree polynomial. Okay, which means that you don't have any techniques to like do anything with this. You can't factor. So the only thing you've got going is graphing. Now, I'm going to pull up my calculator. If you've got yours out, if you want to start punching this into Y1, we can look at this together. So we'll try to kind of hit all 3 together in certain ways. But yeah, let me get my calculator set up here as well.
And we're putting this into Y1.
Yes, the left side will be into Y1. And let me just get mine open. So do you, if you don't have this written down, let me know. I'll just type it in and then I'll switch to that screen.
Oh, I have it written down.
Okay. All right. So let me go to my calculator. 9x to the 4th minus 9x cubed. Are you using your calculator pretty regularly in class?
Yeah, I would say like half the time.
Okay, that's good. All right, so once you get a graph, we've talked this before, but if you just hit the graph button, I don't even know if this will do anything good. It hits, okay. Now it's a 4th degree polynomial, which means that it hits the x-axis at most 4 times. Now I'm gonna squeeze the window in left and right. So the x min, I'm gonna go to minus, I should have counted. I'm gonna go minus 5 to 5. I noticed the y min needed to be a lot lower, so I'm gonna go to like minus 50, and that's just a guess. I really don't know. And then the scaling is important to adjust. The scales like the tick marks between them. So if you've got these numbers here, hopefully we'll see something better. So notice, kind of see a bit more. Sorry if this isn't centered. You see a bit more, but I need to go down further, and I also need to go up a little bit. So I'm going to do that as well. I also can kind of squeeze it in a bit more. 1, 2, 3, 4, minus 1, minus 2, minus 3. So I can really squeeze it in left and right and then go down. So let me do that. I'm going to go minus, I think I said 4 to 3. And then the y man, I guess I'm gonna, so there's kind of a couple of approaches that you can either double or go by 2. I'm gonna change the tick mark to 20 just to give us a little more space in between there. But this should give us a little better window to be able to analyze this. Boy, that's still there. So I've got to yet go down a little further, and I guess I need to go out a little bit more out to the right. So I'll do that. So I'll change my x max to 4 and y min. I hate to go to 200. I'm going to go minus 160. Maybe that'll get it for us. This is probably the hardest part, is to kind of get that. So like the zeros I see a 0 at -2 and a 0 for sure at 3. We can test that using the second calc feature. So second calc, and I'm going to choose 0. 0 is where it crosses the x-axis. Okay, so I want to get that one on the left. I just want to confirm that it's at -2. So notice how it says left bound. Left bound is going to be above it this time, because left of the intercept is a little bit above. You can see there, hit enter. Right bound, I'm going to get a little bit below it, hit enter, and then you always guess in the same place, and it should be -2. Okay, so I'm going to do the same thing on the one on the right. Move this over. There is another way here, but I'll just do it this way. So this time left bound is below it. And yeah, a little monotonous here to get, but just got to be a little bit below it, Right bound, you got to be a little bit above it. Sometimes it goes out of view. That's okay. So you hit enter, enter. And there it is, 3. So we know there's one at -2 and 3. But the question I have, and you, if you haven't done this problem before, I really don't know if the other zeros are nice. Like they might be at 1/2 and -1/2. I really don't know. So I'm going to try it out here. I'm going to go left bound a little bit above it, right bound a little bit below it. Guess, guess, enter, enter. So 0.66667 is actually a well-known number. That's 2/3. Okay, so that's that. We're kind of in luck there. And we'll do the same thing for the last one here. Are you comfortable with what we're doing here with sort of finding zeros? Because that's definitely going to be something that you're going to be asked to do. All right, fantastic. So let me get this last one here. There is another way to do this problem. That one's at -2/3. Okay. All right, so here's another thing they could ask you to do. They could ask you for the min, and the max. Have you been doing that in class?
Yeah.
Okay, so to do that, second calc, and you have to choose either min or max. You have to use the min for the min and the max for the max. You can't mix those up. Left bound this time means left of the min. Enter, right bound, right of it, and so on. Okay, and in this case, you'd have to know to round. The instructors do have an obligation to tell you what to round to. If they don't, go out a couple of decimal places for that. So any questions on sort of just how to graph this one, how to find those mins, maxes, and so on? We're going to do some more of this, but
Not really. It makes sense.
okay. Okay, so let me go back to my other screen. And this problem, it just said to solve. And I wrote the solutions down here. We got all those by graphing. If you looked at the PDF, there's some room to show work. I think this was a synthetic division problem. Did you guys cover any synthetic division in this part of the course? Like, have you talked about it?
Not
It's
really.
okay.
I don't think so.
Okay, that's good to know because I don't know why they give you so much room, but nevertheless they do. Okay, so let's go to a by hand problem. All right, so here is a by hand problem. It would say to solve this. Okay. Any idea how to start something like this?
Would you have the square?
You want to isolate the square. So what we really want is 2x minus 1 squared on one side of the equation and everything else on the other. So I would add 18 to both sides. So whatever is squared, whatever is cubed, whatever is to the 2/3 or 3/2 power, whatever you end up getting, that's what you want to move, or you want to isolate, and you move everything else to the other side of the equation. So now you can take a square root of both sides. Now, when you take a square root of both sides, it's plus or minus square root. You have to do that. It's very, very important. Plus or minus. Okay. So on the left, it undoes the square root, but on the right, this is not a perfect square. And a student once described this as not being friendly because it doesn't work out, nicely. You have to reduce it. So this is prerequisite skill 2 and 9, 3 and 3. Somehow you want to say, okay, I get it. It's 3 square root 2. There's a pair of 3s, so I bring one out. And you are expected to reduce. It's not a, don't hope that you won't get something like this because you probably will. Okay, and then you add 1 to both sides. Now you can't really combine anything with this on the right, like unless you had a square root of 2 to combine with it. You're sort of in this position where you're just going to have this expression that doesn't really look nice, but it's okay. That's what the instructor expects. And then you divide both sides by 2. Okay, so x equals 1/2 plus or minus 3 square root 2 over 2. Any questions on that before we move on to something else?
No, it makes sense.
Okay. I'd like you to try one here. Let's just make up. Let's go 3x minus 4 squared minus 20 equals 0. Just take a minute or two and see if you can solve that on your own, please. I will be right back. How are you doing on this one, Julia?
I got x minus 4/3 equals 2√5/3.
Okay, so it's definitely it ends up being 3x minus 4. I'll just put down some steps here, and then you take a square root of both sides. So yeah, it's 2 plus or minus 2√5 equals 3x minus 4. And then you add the 4 to both sides, so it becomes
Okay.
4 plus or minus 2√5. And then the final step is to divide by 3. So I heard most everything here, but just want to get that kind of solid on this. So okay, good. So we're going to divert away from that and go back to, excuse me, some graphing here. So your the question here, it says it refers to 3 and 4, but for a moment here, here's what we're going to do. It says it says to graph this thing. Okay, so to graph it, you are going to use your well, I take that back here. So this one can actually be done by hand. It's a factor by grouping. And you may or may not know that ahead of time. It does help. So out of the first 2 terms, you can factor out an x squared. And then you immediately write that over here to the right. And you look at the last 2 terms, minus 2x minus 12. And you say, okay, well, I can factor out a minus 2 from both. And that, or there's 2 ways to look at it. You can either figure what to put here, so when you multiply in, you get the previous one, or you can go the other direction. But somehow you have to say, okay, it does work. And then you factor out x squared minus 2. Not really factoring that out. You factor out the x plus 6, but that's what's left over. You may not feel like this is any better, but it does give us more information than we had previously. On the left here, and this is slightly awkward, the left here is an a squared minus b squared, but unfortunately your b is really the square root of 2 squared, which you don't see very often. But the it becomes x minus square root of 2, x plus the square root of 2. And the reason you do this is so that you can find the x-intercepts, because if you go to your calculator, you're going to get a decimal. You're going to get 1.141 minus 1.141, and you wouldn't know that it's a root 2. But I think your instructor is kind of expecting you to know that more exactly. Okay. So the first, like, and one of the things, I know I'm giving you a lot here. For some reason, your school, they give you this like long laundry list of things, and it's very easy to miss some of them. So like I would somehow either label like, okay, that's the first thing I need to do, label on the graph at least 3 points, or circle each thing that you need to do. I need to do the x-intercept, need to do the y-intercept, the vertex, the turning points, the axis of symmetry, and the asymptote, domain, range, end, behavior, increasing, decreasing, and so on. So there's a lot of parts to this problem. So it's not uncommon to either forget or don't do them. So just really pay attention. Like, okay, I got those 3, or hey, I got those when we're done. So the reason you factor is to find the x-intercept. So there's an x-intercept at -6, 1, 2, 3, 4, 5, 6, -6. That's this one. Negative square root of 2, which is just a little bit past -1, and then 1 there at positive square root of 2. And you're supposed to label, so let me try to do that. -6, 0, minus square root of 2, 0, square root of 2, 0. So usually the x-intercepts are the first thing you go for. The next one, it would be like the y-intercept. The y-intercept is when x equals 0. And it also happens to be just this last number, -12. So it's 0, -12 down there at the bottom. And you have a calculator, so you would maybe already know that it starts low and comes down, comes up, and then comes down, and then comes back up. So we've already labeled 3 points on the graph. That's the intercepts. We've got a 4th point there, so we've done that. We've got the x-intercept, we've got the y-intercept. This one does not have a vertex, but what it does have is it has kind of this max, and then we don't know where it is, but there's a min somewhere. So this is where you almost have to go to your calculator to do that. So do you have your calculator handy?
Yes.
Okay. I'd like you to find this point up here on the left for me, and I'm gonna help you. I'm gonna help you find the one down here, because it's not at this point. Well, it might be. But I'll go double check. So do you have this equation written down? As I'm gonna switch screens if you do.
Yes, I do.
Okay. You can do this when you regraph. You can do a zoom standard, which is a 6, and that'll get you back to your standard window, because we did a bunch there already.
Okay.
So you will have to play around with the window a little bit. It looks like, I don't know, we'll say maybe -8 to positive. I'll go 3. I used to be the type of student that really wanted like the numbers to all be consistent, but it doesn't help you in this. So just gotta be careful. Let's go 20. Let's go by 2. We're hoping to see the whole thing, and see you don't quite see the whole thing there. So if for you're trying to find this one up here, so you're going to want to make your window just a tiny bit taller on the Y max. 30. We'll go 30. See if that does it. There it is. Okay, so I'm asking you to do the second calc max. I'm going to do a second calc min for the one on the right. So only a couple of questions on this test quiz, but they're very long questions, lots there. Yeah, so what's interesting is
Mhm.
you can see the min is not at that Y-intercept. It's actually just to the right of it. So I'm gonna write that down, 0.16. All right, do you have any issues finding this point up here? Do you have it for me?
I got X is negative 4.1
Okay, and what is Y?
and Y is 28.1.
Okay, good. And again, just I do not trace. Maybe I hope your instructor didn't say that, but tracing sometimes doesn't get the right position. Okay, so let's go back to the other screen here. And I know there's a lot going on, but you can see here, since you have the calculator, you can just sort of have it trace along there. So we've got it's not really the vertex, it's the turning points is what we just found. The turning. Hey, Julia, it looks like you're back. For seeing my screen, we get the shape of the
Yeah.
graph from graphing it. We also could do it a couple other ways, but you've got to label these key features. So we're doing really good. The axis of symmetry only applies to quadratics. There's no asymptotes. So I guess what I'm trying to tell you here is that not everything will apply to every question. So just be careful. You're not searching for something. Domain, range, and behavior. So the domain here, this is a nice, smooth, continuous function. There is no limitations on its domain. It is minus infinity to infinity. I guess sometimes they say all real numbers. The one on the left is correct. The one on the right is not really, but whatever your instructor wants. The range is like how far down does it go to how far up does it go? Well, it goes down forever. It goes up forever. There's no breaks. So that's going to be minus infinity to infinity as well. But the hard one, I think the hard one is this end behavior. End behavior. So the end behavior is, I almost need a better graph of this here. But so let me just draw a rough sketch of what we got. It goes up and it goes down and goes up like that. So the end behavior, there's two things. As x goes to infinity, and that means to the right. So you're tracing along the right side of the curve, like you're going along like it's a ride, and it's like, okay, well, how far up or down does this go? Well, it goes up forever. So you say y or f of x goes to infinity. It wouldn't matter to me, but check your notes to see what the instructor does. See if there's a preference there for that. Then you have to go the other direction as x goes to negative infinity. And that means you're tracing along the curve to the left. You're tracing along the curve to the left. F of x goes to minus infinity this time. It goes down, down, down forever.
Okay.
And then the last one is increasing and decreasing. So as review, it's increasing, and it has nothing to do with whether it's above or below the axis. Increasing means it's going up and to the right. And decreasing, hopefully you've heard this as well in class, down and to the right. Okay. And you're looking for the turning points, the TPs. So the turning points are the mins and the maxes. So there's a turning point. There's a turning point. Okay. And this is very important, is you use the X values for this. Okay, so the Y values actually are not important. So I think you said this was minus 4.1. And then like I said, this was like 0.2, I'll say. So it's increasing it's increasing anywhere it's going up and to the right. So you can't think of this as down to the left because we read left to right. Everything we look at is kind of left to right. This is going up and to the right, up and to the right. So it's increasing from minus infinity to minus 4.1. But it's also increasing here on this other side, 0.2 to infinity. And again, these are the x values. It's referring to the x values.
Okay.
So then where is it decreasing? Well, you could just choose the other interval and you would be correct. It's minus 4.1 to 0.2, but you're looking for where does the graph go down and to the right, down and to the right. Doesn't matter that it's negative, doesn't matter that it's positive, just where are you going down and to the right or down?
Okay.
So that's a really long question. Really, 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 really long question. And you may find you want to do that one first because it's really long. It takes you a lot of time to do that. I can't really advise you, because I don't know how much time you're going to get, but some students use that as a strategy. They say, okay, I'm going to do the one that's going to take me the longest first. Any questions on that before we move on to something else?
I don't think so. It makes sense.
Okay. All right, so I'm going back through your notes, through these sheets you sent me. Okay, so here is another one. We should probably do another one just like this. All right, so what I want you to do here is I want you to graph it. Actually, let me see here. We maybe don't want to graph it. So let's see if we can use factor by grouping to find the X-intercepts. So in these first two, what can you factor out? What is common to both? And it's a number and a letter.
What's common negative 2x? Wait, which numbers?
Well, between these first two, like what is the greatest common factor between the first two? It's the greatest common factor is what we're looking for.
Oh, 2x.
Yeah, and I'm actually going to use a negative here. So that's going to give us x minus 3. Julia, so we're doing factor by grouping here, and we're looking for the greatest common factor between the first two. So it's minus 2x squared. And then you immediately write the thing that's in parentheses over here on the left, over here on the right. And hopefully it just works. Hopefully you can find a number so that when you multiply and you get back to the original, it ends up being 4. Okay, so then you factor out the x minus 3. And then I'm actually going to switch the order here. This is just something that is a preference. You generally, when the variable is negative, you usually put the constant first. So the reason we do all that is because if we're setting it equal to 0, setting it equals 0, setting it equals 0, we have one of the factors. 1, 2, 3. We got one right there. Now this other one is difference of squares.
Oh wait, Matthew, I think you're muted.
I'm sorry about that. I
It's okay,
muted
no
myself when you jumped off. So what I was saying is if you need to put decimals down, that's fine. Just whatever your instructor is going to give you is good. So it starts over here, ends down here. It's going to come down, up and down. The next thing we want to find is the Y-intercept. Okay, and the Y-intercept is better from the original. So you're going to put in -12. And I don't, for me, I don't care how accurate you are, but the important thing is to label them.
Okay.
I should also label these points as well. It gets pretty, there's just a lot of stuff converging here. You're trying to graph it by hand. So we've got that point down here, but it's kind of the same deal as before. Like it's going to come down and it's going to hit. It's going to come up and hit. Question though is this the min? And I think you'll find that it is not. So I want you to try finding the min this time for me.
Finding the min like on
your
a
calculator. Yeah, on your calculator. If you've got time there to graph it. I'm gonna actually switch to graphing this in Desmos just to save us a little time. But I just want you to do the min for me, please.
Okay.
So it looks like it's just a little bit left of the origin or of that line there.
My graph is slightly different.
Okay, let me new share that screen. Let's see what maybe got going on here. So minus 2x cubed plus 6x squared plus 4x minus 12. Signs, just got to make sure your signs are off there. Let's see here. Sorry, I noticed some sort of sharing is going on here. We don't need to do that. Let's get that off. Okay, so if you're seeing my screen, you're seeing that the you just make sure yours matches up to that, because when I go to graph this, I'm going to do a zoom standard. You're going to see that obviously it comes down up like that. So just double check, make sure you're using the negative, not the subtraction. That could also cause some issues. What do you see? Is it looking like?
It looks the same on my end, which is weird.
Okay. But yours is not looking like this.
No, mine starts, yeah, it starts in the left quadrant and then it like crosses the y-axis.
Okay, maybe how's your window look? Is it like this? And if it's not, do a zoom standard for it.
Okay.
See if that gets it.
Okay, there we go.
All right. So one of the things we do have to do here is we have to tighten up around the x's, and then we're gonna need to go down on the y. So I'm gonna go back to window. I'll go -5 to 5, and then again, kind of your strategies are to like double. So we'll go down to -20. We'll see if that's enough. And let me change the scale here to 2 just to make the tick marks a little easier. So I'm gonna go back and graph. Yeah, there it is. Okay, so I'm asking you to find the min, and now that we have a nice window, you can actually see the min is not at that Y-intercept. It kind of looks like it might be there, but it's not. So can you calculate that for me, that min, please?
Mhm.
Let me know when you have it, please.
The minimum for X is negative 0.29,
Okay, agreed. And the Y value?
and the Y is negative 12.6.
Good. All right. Great. So just, remember that window stuff. I know it's a lot. I mean, if you're going to take more math, you will use this calculator again. So that's the reason to keep kind of working through this. So here's your graph. It looks so much better on a calculator or Desmos, but this is our graph here. It's all labeled. So there is no vertex this time. There is no axis symmetry, but we did get the turning points. We got those. There are no asymptotes. So we're now up to domain and range. So this is nice and smooth and continuous. Your domain is all real numbers.
Okay.
Same with your range, because it goes up forever and it goes down forever. So for a nice smooth one, we're gonna just assume that it's always minus infinity to infinity. Now I'm gonna redraw the graph just so we can get those get that next stuff answered. The graph comes down like that, not to scale. And I'm just going to one decimal place here. So minus 0.3. And then this one is 2.3. Okay. And if I ask you, where is this graph increasing? Increasing means it's going up and to the right, and it's just in this middle section that it's going up and to the right. So, and it's only the X values. Notice, like, I didn't even write the Y values because we don't care about them. It's from minus 0.3 to 2.3. Decreasing, well, that's the other intervals. So minus infinity to the X value, minus 0.3. And then the other one is over here where it starts at 2.3 and goes to infinity. Again, X values. It's awkward the first time you do it. It's just the X values that you care about.
Mhm.
And then the last thing is the as X goes to infinity, as X goes to minus infinity. So X going to infinity means you're tracing the curve to the right. And then once you sort of stop going up and down, when you actually just keep going in one direction, it's like, how far down are you going? How far down are you going?
Mhm.
And the answer is you go down to minus infinity. But when you go the other direction, as X goes to minus infinity, that means to the left. So you can literally trace the curve to the left until you're only moving, up, either straight up or straight down or something like that. And you can see that f of X is going to positive infinity, or just infinity.
Okay.
All right, so let's see if we covered everything in that one. There's so much there. Yes, domain check, range check, and behavior check, increasing, decreasing check as possible. So the instructor is expecting you to know when something is or is not possible. We definitely labeled a couple of points there.
Okay.
All right, well, I think that probably is a good place for us to stop here for this first hour. Please use that other booking link for 8 p.m. And I will see you in about 10 minutes.
Okay, thank you.
Thank you. See you shortly. Bye.
Bye.